This is a tutorial about scientific notation and units as seen in Chapter 2. Scientific notation is an abbreviated way of writing a very small number or a very big number. So for example, if we had the number 1205 and we wanted to write it in an abbreviated format known as scientific notation, the rule is you place the decimal after the first non-zero number, which would be seen right here. So it would look like 1.205 times 10 raised to the, well, let's see, 1, 2, 3 places. We had to move the decimal 3 places. This number is basically showing a condensed version of 1205. In other words, scientific notation shows how very large or small numbers can be expressed as the product of a number between 1 and 10 and a power of 10. This 3 shows how many place values we condensed it to. Now, if we want to look at a very small number, let's take a look at that. Let's try the number 0.0002. And we want to make this number, or put this number into scientific notation, then we do the same thing. The decimal needs to go behind the first non-zero number, which is seen right here. Here's the first non-zero number, and here is behind the first non-zero number. Then we have to see how many times we move that decimal over. 1 place, 2 place, 3 place, 4 places. So we have 2 times 10 to the negative, again that's 1, 2, 3, 4 places. 2 times 10 to the negative 4. If you notice, our exponent now has a negative sign indicating a small number. When you move the decimal place to the right, your exponent gets a negative sign. Let's take a look at one more example. Let's try the number 20000. Again, you're going to place the decimal behind the first non-zero number, so that's 2 point. And now all of these zeros here do not need to follow. So you could just leave it even as just regular 2 with no decimal, and then go back to writing it in scientific notation, and that is times 10. And let's see here, to get that decimal behind the 2, we moved it over 1, 2, 3, 4, 5 places. So we're going to put a 5 here. Again, if you would like to put that decimal there, you can, though it's not necessary in this instance. So this number tells us that originally we had a number that had 5 place values as seen over here in the original number. For homework, you should turn to the back of Chapter 2, where it says Chapter 2 Review in the textbook, and look under the Scientific Notation 2.1 section where you see where it says Questions and then another heading that says Problems. You will do numbers 3, 4, and 5 on a piece of notebook paper following the notes that you have taken on this lesson that you learned today with me. Again, that's numbers 3, 4, and 5 on a piece of paper to be checked in. Our last topic we're going to be talking about is the word units. Unit is an abbreviation that is put behind a number to indicate what type of measurement you did. For example, if you have the number 12, the unit follows the number as seen here and is an abbreviation. So this is 12 centimeters. Another example would be something like 5. With a little m following it, this would be considered 5 meters. The unit always follows the number at the end. This is the measurement, this is the unit. This is the measurement, this is the unit. When talking about units, there's two important systems to know, and that is the English system, which we use here in America, and the metric system, which a majority of the rest of the world uses. The English system has many popular units that you've probably learned before, and that's such as feet, inches. The metric system has meter, centimeter, liter. In science, we will be using the metric system. Please make sure that all of your units follow the metric system. Only some of our measurements will be done in English, very, very rare. So if you're not sure, you refer to the metric system.